Thanks for joining us today. We are very excited to have you on. In this webcast, we will be showing you a demo of GitLab CI/CD advantages over Jenkins. My name is Agnes, and I work on the marketing programs team here at GitLab. I'm joining you from Bali, Indonesia today. We'd love to hear where everyone is tuning in from, so please use the chat function to say hi. Before we get started, I'm going to cover a couple of quick housekeeping items. First, feel free to ask questions throughout the presentation. You can use the Q&A function at the bottom of your screen for that. We'll have dedicated time for questions at the end of the webcast, but you can go ahead and send in your questions as you think of them, and we'll make sure to get to them at the end. If you're experiencing any technical difficulties, please use the chat function to get in touch with me, the moderator, for help. Our presenter today is GitLab Technical Marketing Manager, Itzik Gan-Baruch. Also helping us with Q&A is GitLab backend engineer, Steve Azopardi. We're going to launch 2 polls at the beginning of the webcast, so we learn more about you. That way, Itzik can tailor the presentation accordingly. With that, I'm going to launch our first poll. All right, thank you so much for participating in the poll. Looks like a majority of you are currently using Jenkins, so the presentation today will be highly applicable to you. And now on to the second poll. All right, great. And thanks again for participating in the poll. Looks like a majority of you are already using GitLab for repository. So it'll be really interesting to see how you can expand this use case. And with that, I am going to turn the presentation over to Itzik.
Thank you, Agnes. And welcome to the webinar. So the agenda for today, we will discuss about key differences between Jenkins and GitLab. And then I will introduce the main problems that GitLab solves. After that, I will show you some Jenkins challenges that we hear from Jenkins users and the main challenges, and how GitLab does it better. And we will follow with the GitLab demo end to end. And we will have, as Agnes said, we will have a time for a Q&A at the end. Right, so I'm not going to compare a difference feature to feature, feature by feature, because basically whatever you can do with the one tool, you can do with the other tool or vice versa, but it's the different concepts. Just I want to mention that when I refer to Jenkins in this webinar, I refer to the open source Jenkins, the free version of Jenkins. So Jenkins It's actually an automation tool. It's used for automations and leverage to make a CI, continuous integration. For basic functionality, it relies on community plugins. Means for version control integration, issue tracking integration, like Jira, security, reporting, Docker. For every basic functionality or anything that you need to do with the Jenkins, you will have to find the proper plugin for that. While a GitLab is a CI, but much more than CI. GitLab is a complete DevOps platform. When you have a GitLab, you have a complete CI/CD out of the box, but not only, you have also a version control, SCM, security testing, issue tracking, monitoring, and thousands of features. Everything delivered as a single application, one installation, one interface, one conversation, and one permission model. We make it simple to develop and to implement DevOps, modern DevOps. And another key difference is the time when the two products have been started. So Jenkins is relatively old technology, started on 2004, was not designed for supporting cloud native development. While GitLab started on 2014, was built from the ground up for DevOps, and it's based for a modern technology and developed for cloud native, Kubernetes, and containers. So these are the basic things. Now, of course, every feature, most of the features that you can do in one tool, you can do with the other tool with the plugin. But these are the main differences of the mindset of the tools. So what are the problem that we're solving? DevOps organizations trying to implement DevOps, and the reason for that, they want to stay competitive. They want to release faster. So they use sometimes legacy tools or tool chain, and sometimes those tools are not tools that was built for DevOps, like all tools. So they're using integrations and patches and end up with many tools integrated together, and this complexity slows down the DevOps. And also it introduces complexity and security risk and compliance risk. And different data models means that you don't have a transparency. Different teams talking with the different metrics, different languages. So this is what GitLab solve. So I believe everyone familiar with this graphic of the DevOps, that you're starting from planning of what you want to do, creating, verify, package and release, configure and monitor, and then you get feedback back for the planning. So GitLab has a solution for each one of those stages. Here are another view of the stages: manage, plan, create, verify, package, secure, release, configure, and monitor. And we have a single experience to implement DevOps. Right, so now I want to discuss about a few challenges that we hear from Jenkins users. So first of all, Jenkins, of course, everyone knows is free. You can get Jenkins for free, but the total cost of ownership, it appears is high. And also it has high maintenance. And this is because the machine that you need to maintain while you have Jenkins, you have a large set of a build environment that you need to manage, install the build tools on that. I heard a lot of Jenkins admins that they scared to upgrade Jenkins because from their experience, they upgraded the Jenkins and then 4 days the system was down. And the same of Jenkins plugin. If you want to upgrade plugins, maybe you will solve one problem, but because of the plugin dependency, you can break another plugin. Groovy, some people like Groovy, mainly people who are familiar with Java, but not everyone knows Java, not anyone knows programming. So it makes it very complex to use Groovy. because it's software language, you can create a complex logic that then it will be hard to maintain. Of course, also here that people, because there is no debugger, they print to the console some messages in order to debug, which is take more time to solve a problem. And Jenkins also let you to do a lot of automation. It's not used only for a CI or CI/CD. Every automation that you need to do in your organization, you have Jenkins and you build that. It allows that. And at the end, it becomes hard to track, to backup, and to debug. As I mentioned in the introduction, Jenkins, all the capability relies on plugin. On one hand, it's powerful because you have a plugin for everything that you need. You have a plugin, but some of the plugins has a quality issue, stability issue, and sometimes you need to waste a lot of time instead of spending time on your development, on progress with your task. You will need to waste time on plugin quality plugins. The people who write those plugins sometimes are part-time or hobbyists, and there is no real support for those plugins. We heard that not all of the documentation is clear, and sometimes there are many plugins that do the same, and you will need to spend a lot of time to understand which plugin will solve your problem. Or maybe you will install that one, and then you will say, oh, this is not good. And then you will need to install another one. Of course, each plugin has dependencies and leads to compatibilities issues. And of course, Jenkins, because of the plugins, there is a lack of visibility and control. If we are talking about enterprise, that every team will download the plugin for its needs, the operations team or CTO team or security team doesn't have a visibility in what the team's downloading and installing, and missing alignment, and large enterprises don't like to work this way. Another point is that Jenkins, as I mentioned in the beginning, was not designed to work for the Docker. So again, you can have multiple plugins and have containers, but it's not a functionality that they come out of the box. For example, if you go to the Jenkins plugin catalog and you look for Docker, you will find 26 plugins with the name Docker. So it's really hard to understand what you need. And when I say Docker, it's not only people, when think about Docker, they think about, oh, how I will deploy the application. But it's not, Jenkins is a build tool. It's also, usually you don't use plugin, you don't use Docker for the build. Normally Jenkins uses VMs to do all of the CI, the jobs itself, while modern CI tools use Docker to make actually the CI/CD, which make the life of the developers much easier. Some more issue that we keep hearing is scalability issues. You know, Jenkins does not support clustering. So if you have a big team that are hitting Jenkins, you have only one machine and should have a very high resource machine you will need if many people are accessing the Jenkins. We talked about plugins security because they are have been written by third party. There is no guarantee that they are secured. Maybe they introduce some security breaches to the organization. Another point is access and permissions. You install Jenkins, you need to manage, you need to take care for who is accessing the Jenkins, to which modules, and what level of permissions that this person have. In Jenkins, it gives you to do everything, but you are the owner. You need to think about everything, and you need manually to think and do everything. And of course, lack of auditing and compliance. And again, visibility and collaboration also missing in Jenkins. I think this is the last point that I want to mention. One of the main points is Jenkins is just CI. There is no CD for Jenkins. So people say, yeah, we have CI CD. When they say CI CD, they have CI with Jenkins. Jenkins give you the build, the artifact packaging, testing, and pull request handling. But for the CD capabilities, you will need to write complex custom deployment script, and also will need to use Ansible or Chef or a third-party tool with the plugins to make the CD, which also cause to complexity and so slow down your delivery. Now I want to mention a little bit about Jenkins X. Jenkins X is a new functionality, new technology from Jenkins that trying to solve some of the issues. Mainly Jenkins X bring the CD capability. So with Jenkins you can do CI/CD, which is a really great step for a modern and development of cloud native application. But the challenge with the Jenkins X, it's not a new code, it's not a replacement of Jenkins, it's take the old Jenkins 2.x, and on top of that, it installs a patch. So behind the scenes, it inherits all of the old Jenkins problems that I just discussed, maintenance, plugin, upgrades. And another point for the Jenkins X that it introduced, so gone of the days that you can you have a conflicts problem and the team say, okay, I have now conflict in my Jenkins master. I have here another machine. I will quickly install Jenkins and proceed with my task. So gone of those days, because Jenkins X has very, very super high system requirements. So we will need to have very strong machine to run the Jenkins X. Another thing, at least for now, that the deployment is limited to Kubernetes clusters. You cannot deploy to anywhere with Jenkins X. It comes with the command line interface. There is no UI for Jenkins X. And it still uses the Groovy, which we spoke. It's not the best language. Not everyone living good with the Jenkins. For now, I want to switch to how GitLab does it better and what is GitLab actually. So GitLab, first of all, is one tool. You have the SCM, which is the version control, and CI/CD in one application, together with issue tracking, security testing, everything, and monitoring everything in application. So for all of the basic things that you need for CI/CD, you don't need any plugin and any customization. Now, we spoke about upgrade that people scare and don't feel good to upgrade Jenkins. With GitLab, it's very easy. GitLab release a new version every month, every 22nd of the month. And if you need to upgrade GitLab, it's just to replace one Docker image. You replace one Docker image, and it replaces for you not only the CI/CD, it replaces for you the version control, the issue tracking, all of the tools. In one replacement of a Docker image, you upgraded without a risk your entire tool chain for DevOps. And of course, GitLab is optimized for containers. It has built-in container registry and Kubernetes integration, cluster monitoring, review app I will show you in the demo. And developers, they have visibility the entire development lifecycle. A little bit I want to deep dive about the runner execution architecture. So GitLab Runner is the agent that run the CI/CD jobs. It's written in Go, so you can install it anywhere that support Go. Out of the box, it has native Docker support. And when I say Docker, means that all the jobs can run in the Docker container. Actually, when a job, if you look on the script here, this is a job definition that we define in our CI/CD configuration file. So this is the job name, and here we did specify the name of the image and the service. And this is the script run. Means when the job will start, the runner will go to Docker Hub, will download those image and service, and will run on the script on the image. So there is no you don't need to install pre-install any build tool on the runner machine. The only thing that you need to install on the runner machine is the Docker. Make your life much more simple. And in the job, you don't need to take care for which runner to use when you run a specific job, because it's not matter, because anyway it run with an image that it downloaded when the job starts. And when the job ends, it remove the image and revert back the machine to the previous states. This is also solved as a big security bridge because it's clean up all of your data. GitLab Runner support built-in auto scaling. So machine can create it on demand for jobs. And this way you can save money, because if you're running on the cloud, you have machines up and running only when you need them for the job, but not always. There is a timeout, and when the job ended, those machines are no longer costing money to you. And of course, it has simple configuration to enable scaling jobs and running concurrent jobs. So this is I talked about the GitLab Runner. This is actually the agent that executes the jobs. And here I want to talk about the CI/ML. This is the GitLab. This is the brain. Here is where we defined the CI/CD. On the right side, you see an example of GitLab CI/CD configuration. It uses a structured YAML format. It has shorter learning curve, and it make it very simple to track and understand what is going on, because all of the script is not on all of the logic. It's outside of this configuration file. And of course, this file, like in Jenkins, is a part of like Jenkins 2.0, like the Jenkins file actually is a part of the repository, means it's versioned. So in this just example, how it works, here you have a 3 stages: build, test, and deploy. And you see 2 jobs visible here: build and test. And also we define the global image. So this is the default image that each job will download. Oh, sorry. But if you notice here, test also have an image. So while all jobs will download this image, I can define for a specific job that I want a different image. Also, it supports caching to accelerate the pipeline. This is another screenshot of our single permission model. So in GitLab, you can create a group, and there you can add or remove users. We have 5 different roles and permissions. On the left side, you see those level of permissions. And we have documentation that shows what is the access level for each of the roles. And when I say roles and permissions, it's because GitLab is a single application. Same good for CI/CD, for the issue tracking, for the version control, for monitor, for everything, for Kubernetes integration, for container registry, one permission model. All right, so I think this is the last slide. This is what analysts think about GitLab. And as you see in the Forrester report, we got leaders in 2017 and 2019, very recent report. Demo. All right. So what we see here, this is a GitLab. This is a GitLab project. Here we can see my source code, very simple Spring application. On the left side, you can see different links. First of all, the project. You can see I'm now in the project details tab. This is what I see when I go to the project details. I can see releases. I have security dashboard, dependency lists, cycle analytics, which tells you how much time spent. Actually, it analyzes the entire DevOps and tell you how much time spent on issue, how much time spent on the testing, on development, on each of the life cycle stages. you have in one report, you can see all of the stages. Here is the access to the repository, to issue tracking, to merge requests, CI/CD operations. This is all of the environments that you have that I will show you in the demo. Packages, for example, container registry, and the project settings. Okay, so I want to show you uh, how we can configure, connect the Kubernetes. So I have here for the project details, I can click here and I can add Kubernetes to this project. This project already configured that I just want to show you. There are two ways to add Kubernetes. First, we have integration with the Google GKE. So by clicking here, you can, with the form, you can submit a few parameters like name or more 2 or 3 parameters. And then with the API, it will create for you a cluster in GKE. But if you have other cluster, any cloud vendor that you have, or even your bare metal, you can have existing Kubernetes cluster. You use this tab and add the Kubernetes. And this is the way that you can set up a Kubernetes. I want to show you another feature called GitLab Auto DevOps, and I will enable the Auto DevOps. So Auto DevOps, by clicking this checkbox, it will set for me the entire full CI/CD based on pre-configured CI/CD YAML template. Means it will build for me, once I have a source code, automatically it will build for me the application, will test it and deploy it via a different deployment strategy that I will define. I will show you later. So I just save changes. And let's go back to my project. So I have project with the source code. I have Kubernetes configured, and I have Auto DevOps enabled. Now I want to show you a simple development flow. So I will go to the issue tracking, and I will create a new issue. I will assign the issue to myself. Right, great. And I will go to the issue boards. And because it's a new project, I don't have the board. So GitLab, by the way, when you're starting a new project, always it tells you what is the next step to do. You don't need to think, here, for example, you say, it's a new board. So it suggests me a default list to do or doing. And you ask, you have your list. But in this case, I say, no, I'm fine with to do and doing. And I will just drag and drop my issue I just created. So, okay, I'm done. And now I will go to the project and I will open the web IDE. So this is a build web IDE that GitLab adds a very nice features from one version to another version. On the left side, you can see it's open the source code in the context of the project. You can define which branch you want. So I will navigate to my source code, and I will make a simple change here in my HTML file. All right, changing the code, I will click commit. I see the changes side by side in the web IDE. I will stage this change and click commit again, add a commit message. Now I will create a new branch, give it a name. I started with one because I want to now manually have a link between my branch and the issue tracking. So once this branch will be merged to the master, automatically issue number 1 will be closed. And start a merge request. It will open for me a new merge request. Merge request is a basic thing in GitLab. If you are Bitbucket or GitHub user, it's called pull request. But the right name is here we're trying to merge our feature branch into the master. This is why we call it in GitLab merge request. So I will start with the market with the work in progress. When it marks in work in progress, nobody can accidentally merge it to the master. Automatically, it says, okay, it closes issue number 1. I will assign it to myself. And here it tells me, okay, this is your feature branch. You are asking to merge it to the master. I will delete the source branch once the merge is accepted, and I will just submit the merge request. All right. As you can notice, a new pipeline automatically started for me. And this is the CI/CD created. So here we see a few stages. We have build, test, review, dust, and performance. Let's dig to the build. You can click and see actually the job logs. And what it does is actually download a Rocco build backpack image and actually build a Docker image for my job and push it to the Docker, to the container registry. Right? After the build ends, this is the second stage, which is a different tests. All of the jobs we're running in parallel. And what it does, and this comes from the auto DevOps, you're doing quality testing, scanning for container, for vulnerability in our containers, scan for dependency scanning, all of the code dependency, check if there are any vulnerabilities. It does a license scan, because we're using a lot of open source and a lot of dependencies. We want to make sure that all of the licenses not violate our company policies. And it runs for you a SAST, static application security testing, and more unit tests, etc., etc. Now I see the build just completed, so I want to show you how it created a Docker image from that. So I'm going to the container registry, and this is the image that it just built for us and created for us. This is really image that I can download it to my local machine or do whatever I want. Let's go back to the CI, to the pipeline to see more things. Okay, so the testing is almost done. And now it's running the review app. Review app is, because we are running on a Kubernetes, this project is integrated with a cluster that I created in Google. It will create for me a personalized live application for my commit. So each developer will have a personalized live application that will be part of the review. So you can send it to your colleagues, to UX person, to UX, to PMMs, to see the really live application. Moreover, now because we have the live application, we're running dynamic application security testing on this live application. And once this stage actually will be completed, we will run a performance testing on this review app. This is a huge shift left because we just pushed a commit. We didn't merge it, and I have a personalized live application with testing running on that. So it will give me a lot of information, and it will identify a lot of problems before I can decide if I can merge it or not, and I can quickly also fix them. So let's go back to the merge request and see how it looks. So now I have a view app, a new button added, and this is the review app. So I will click on that, and I can see Tanuki powered by GitLab Technical Marketing. This is my change. This is a live application, not in production yet, but this is a real URL on my Kubernetes cluster that I can send and let people review this change. Moreover, all of the test results coming here into the merge request. So for example, it didn't detect any code quality issues, But for example, it detected, the SAST detected 4 vulnerabilities. So I will just open the full report. And here I can see the SAST and DAST. And this is a cool thing because I have one application, one dashboard, which I have SAST and DAST. So imagine if I had to do this, for example, in Jenkins, I needed to integrate with plugins with 3 or 4 different products in order to, and then handle all of those reports. It would be a lot of complexity, which here is very simplified. So let's see what those SAST and DAST bring to us. Those are the descriptions of the vulnerabilities. So if I click here, for example, it opened for me a dialog with a description, with a file, actually the Java file that involved or this led to this vulnerability. If I click here, I can see the file and even the lines, it highlights the lines of code of this vulnerability. Moreover, I can see the identifier. So it will be easy to developer to understand what is about this vulnerability. And okay, I see it's a real problem. I want that someone will fix it. So with one link, because we have everything in one application, I click here. It is creating for me issue in our issue tracking. Fill for me all of the details. The only thing that I need to do, assign it to a developer or to someone. In this example, I will assign it to myself. A person got this task can immediately solve the security issue. And in security, some organizations doing development and leave the security for the end. And then a few days before the release, the security team come with a list of requests that nobody can understand how to solve that, put a lot of pressures on the developers. Here it's make it very shift left. Developers have all of the information right after they push the commit button. Very, very helpful. So because we have here, we can see the dependency scanning, container scanning, all of those tools in one dashboard. I will not show everything, but I want to show you the dust because we have the live application. So here, for example, he found for me a cross-site scripting. So here again, you have the identifier, which said it's a cross-site scripting. But also, if I click on this link, it opened for me the review app. And this is the area in the application that led to cross-site scripting. And I tell you what was the problem. In this application, whatever I type here and click submit, it just print it out. So imagine that I will type a script and submit. Someone can abuse this and write script and get information or hijack my website. So this is how I detected it. Right. Oh, by the way, this is the Google Cloud Kubernetes cluster that was created before the demo, created by the integration. I want to show you also the license scan that we have here. So we scan all of the code, and this is the list of licenses that he found. And for example, if you want, you can mark one of them and say, okay, Apache, I want to add to the blacklist. And for the next time, it will appear with the error because you're using a license that not following the company policy. Right? So I've seen the live application, I've seen the testing. I think in this case, for this demo, I want just to merge it. I say it looks good. And I will resolve the work in progress. Now it will close issue number 1, and I will click on the merge. Now I'm merging my branch to the master. And if you will notice, another pipeline automatically started for me. A little bit different because here we have a 4-stage build test, but here we're deploying to production. Now, quickly, I want to show you how I create a tag because we have released a new version. So I can from here create a tag, give it a version. I will paste some text, and I'm creating a tag for my release. If I go to project releases, I have here release, version, release notes, and also I have all of the source code of this release that I can download. Right, and also it gives me, I have artifacts that I can download, and artifacts can be the source code, but also any artifacts that I defined in the CI YAML can be a test report or any output that I want to have put as an artifact. I want to go again to see the pipeline, and all right, so the test still running, and soon we will deploy to production. Right. So now in the few minutes that left in this demo, I want to show you the operation side, the production side. So I will go to the operation tab, and I will go to environments. And here you can see a dashboard of all of the environments that I have. Here I have two environments, the production and the review. But if I have VMs or other environment, I will see it here. This green box is represent one pod. So if I click on that, I can access to the pod log in Kubernetes. And this is huge because if I had to do it without this integration, I had to go to another application, do a lot of clicks until I got to that. Moreover, it's if I had to give to someone else, a developer to see it, if I'm an operation and I need to developer to see what is the problem, this developer usually doesn't have access to that. So I need to send him my access, or it can lead to a security risk. But here you can access, if you have permissions, you can access to the pod logs. Moreover, you can see all of the commits in the production. And you can see here access to the live application. You see, this is the product, the application that our customers are using. You see it? And one of the last things that I want to show, I know we don't have too much time. We want to have some time for Q&A. So this is environment variables that you can define all of your environment variables that you don't want to put on your CI/CD. In this case, I want to define production replicas. And this is environment variable that will allow me to scale my Kubernetes. I will assign 10 to this variable. And I will go back to my environment. And I will refresh, redeploy. And now it will scale up my environment soon. Let's refresh screen. So I scaled up the environments in Kubernetes. I have 10 pods. We have monitoring because this is part of that comes out of the box. So developers also have access to the monitoring of the application. So again, if I had to do that in Jenkins, I had to go to another tool and waste the time with the permissions. But here you have access to the monitoring, but no more. Moreover, you can correlate now between commits and some metrics. So if I click, for example, here, and click again here, it will open for me the commit that lead to this matrix to raise. And of course, you get some Kubernetes metrics as well. So I think really the last thing that I want to show you here is that you can have access, web terminal access to the container itself. For example, I can click here any command, and if, for example, you have problem in production, the developer has access, can see logs, can see config files or change config files, whatever he wants, which it's also flexible to go to this environment. So with that, I will just end the demo, and I will just have a quick recap, and then we'll open it for Q&A. So what I showed you now is that with a single application and single UI, we made the following changes. We created an issue and made a simple code change with the web IDE. CI/CD pipeline started, run build, test, deploy, run dast and performance testing. A review app created for us, Docker image created and pushed to the registry. And then we reviewed the test results and accepted the merge request. A new pipeline started, deployed the new code to production, and then we were able to access to the production, see the UI of our application, see the logs, the pod logs, see the monitoring, access the web terminal, and everything in one single application, single experience. And now let's back to Q&A.
All right. Thank you so much, Itzik, for walking us through the GitLab CI/CD demo. Onto Q&A, we have a lot of good questions come in the chat. So I think Steve has been helping answer some of that, but let me kind of get started with the ones that come in through the Q&A section for now, the Q&A box. So the first one from Mike. Mike asks, is it possible to hide variable value from maintainer?
Again, second?
Mike asks, is it possible to hide variable value from maintainer?
From maintainer?
Yeah.
So as I showed, all of the parameters we defined in the CI/CD settings, regarding, and there is you can define the specific access for those permissions, but I don't have actually the immediate access answer if it's from the maintainer or but I believe it's flexible because you define to which, Steve, maybe you want to comment on that?
Yeah, so by default, all maintainers of a project do have access to the variables inside of the CI/CD section. But we are working on a new solution to use HashiCorp Vault that will help prevent those kinds of issues. But at the moment, right now, maintainers can access variables, secret variables.
Okay.
Thank you, Steve. And Itzik. All right, the next one, someone asked, are we comparing open source Jenkins features with open source free version of GitLab?
Yeah, so a good question. So in this demo, I showed you some of the things are part of the free version, and let's say like that. In Jenkins, everything is free. The product is free. GitLab has a different model, so it's open core company. So the basic functionality, repository, basic CI/CD are free. But for example, security testing currently is not free. You have to pay for that. So more functionalities are not free. So not everything is free, but we have also free tiers. I hope this answers the question.
Yeah, this is Dan. It's worth also pointing out that those things that are not free, like the security scanning, are things that, as well as with Jenkins, you would also need to pay for a third-party company.
Right, thanks. Good point.
All right, the next one, Carlton asks, can the GitLab runner run independently of GitLab? For example, does not depend on or have to use GitLab?
Steve,
I can probably answer this. GitLab runner depends on GitLab. It cannot run without GitLab. It talks to GitLab and nothing else. And then for the GitHub integration, for example, it does require GitLab to be available.
All right, thank you, Steve. Diego asks, is it possible to use GitLab runners for executing end-to-end tests with mobile devices?
I can answer this one as well. Yes, it can. For example, if you're using iOS, you can use Fastlane build as well. One of our product manager on our blog post wrote a nice article on how to do CI/CD with Android apps and iOS apps. So I will send that on the chat.
Awesome, thank you. And then someone in the audience asked, does GitLab CI have artifacts build output, and can I examine the build workspace after a build?
I can take this as well. Yes, you can upload artifacts. You can either upload them to GitLab itself or directly to an object storage like S3 or Google Cloud Storage. Now, regarding the environment, to look at it after the build is done, it really depends on what kind of environment. For Kubernetes, no. But for example, if you're running the shell executor and you're running on a VM, you can. We do have plans, right now we do have the interactive web terminal, and we do have plans to iterate over that to support and SSHing into a pod or a container after the fact that the build is done. But that's a work in progress.
Great, thank you. And Rick asked, can we integrate third-party security tools, or do we need to use the security tools built into GitLab?
You can always run your third-party security tools, of course, but what you won't get is the view inside of GitLab itself. So to get the view inside of a merge request or inside of the GitLab dashboard, that has to be with our security tools. But for example, if you just want to use GitLab for repository and CI, and you already are committed to a security tool, you can still have GitLab CI call out to that security tool.
Awesome, great. And then Sean asks, regarding on-premises deploy environments, is it easier to use the on-prem installed version of GitLab with all maintenance involved, or linking online GitLab through firewalls, etc., to host in-house?
We have customers doing both. It really depends what you want and how much you want to manage yourself. You can install GitLab Runner on your own infrastructure and talk to gitlab.com. The way that works is you don't really have to expose anything from your system, because GitLab Runner talks to GitLab. It's not the other way around. So you don't have to poke holes in your firewall or anything. You just have to have your firewall allow outbound connections to the internet. So then GitLab Runner will talk to gitlab.com, and then GitLab Runner will just deploy your on-premise infrastructure.
Awesome, thank you so much. And Josiah asked, my question, I would like to know how to get the community version of GitLab to the CI/CD overlord.
I'm not too sure what they mean by that question, to be honest. So if they can clarify it.
All right. Harsh asks, is it possible to integrate MATLAB MathWork codes for CI/CD and running unit tests?
Yes, it is. It really depends on how MATLAB is set up, but if it's set up on a specific VM, you can have GitLab Runner SSH into that VM, run MATLAB on that and then throw back the results. So it really depends on how the setup works. But yes, with GitLab Runner, you can execute any bash script at the end of the day.
Awesome. All right, we have about a couple more minutes. So there's a lot of really, really good questions. Thank you for submitting these questions, everyone. We'll try to get through as much as possible, but if not, then we will send over, the answers to you via email. Dejan asks, is GitLab able to set up in-house Kubernetes cluster?
It is, yes. So when you go to set up your Kubernetes cluster, you have two options. You can either install it with GKE and it will create a new cluster for you, or you can bring your own existing cluster. That will take some more involvement because you have to put in some TLS certificates and all that, but you can have your cluster running on bare metal or on OpenShift or somewhere else. So you can definitely bring your own cluster. I will send a link to the documentation on how to do that in the chat.
Awesome. Thank you, Steve. Kasish Vanath asks, is there any support for SonarQube integration in future GitLab releases?
Not that I know of, but keep in mind that GitLab has a public issue tracker. So you can either go search for there or create a new issue and we'll take a look at it and prioritize it accordingly.
All right. And another person asked, how does GitLab security scans compare to other players in the market?
That's a really hard question to ask, just because security scans are by default, they're like most companies are very secretive on how they're doing it and what they show you. So it's really hard to answer. But what we're doing at GitLab is we're relying on open source tools. So we're relying on OWASP tools and ZAP, for example, and things like that. So we are quite competitive in that market.
Awesome. And then, we have a really, really good amount of questions coming in. So we have 3 more minutes. So I think we'll go through maybe 3 or 4 more of these. So Wilhelm asks, do you have tight integration with Amazon Web Services as with Google?
Depends what kind of tight integration you mean. If it's setting up a Google Kubernetes cluster with one click, no. But you can still deploy to EC2 instances. You can still run CI/CD jobs on Amazon Web Services. We have multiple customers running auto-scaled runners on Amazon. So it's we do integrate with Amazon quite well as well.
And we are actively working on that capability as well. It should be released any month now. So.
Yeah.
Awesome. I think Josiah clarified, he meant, is there an easy way to upgrade for folks that are still testing our product?
Yeah, so you can always run GitLab Enterprise Edition without a license. That would mean that you're just running Community Edition, which is with just a bunch more code, but it's not doing anything. And then if you really like what you see, you can always upgrade. We also provide free trials for GitLab Enterprise Editions, but you have to go through our sales people to set that up for you.
Awesome. Hopefully that that answers your question, Josiah. And Aaron asks, we leverage Jenkins shared library for consolidating business logic and implementing custom integrations across builds. Is there an equivalent mechanism in GitLab CI?
We do have one, yes. They're called GitLab CI includes. So I will send you a link on the chat. But GitLab, you can include multiple GitLab CI files. For example, have a project that has like shared libraries. For example, let's say I want to have a GitLab CI YAML file for Maven projects, right? So then a new Maven project comes in and it will just include that GitLab CI YAML file. We also have more. We have included templates. For example, GitLab provides some templates. So for example, the auto DevOps pipeline is included as a template. So you can include that and then build on top of it. And you can also have instance-wide specific jobs as well. For example, if you want to run a security scan for every project, no matter what, you can configure that in the GitLab admin.
All right, thank you. And I think that will be the last question because we are at the top of the hour. Again, if we did not get to your question, we will email it to you in the next few days. Thank you, Itzik, for the informative session, and Steve and Dan for tackling all the questions. That's all for today. Thank you so much for joining us. We will be sending over the recording from the webcast in the next few days to all attendees.